This is the third lecture, the online version of it, in systems analysis and design. And today, we are going to cover systems development methodologies. Here is the presentation outline. We shall first have a brief introduction to systems development methodologies, what these are, why they're important, and why an ICT project should take one for systems work. And the methodologies are quite many. We're going to discuss approximately 9 of them, starting from waterfall model. After waterfall, we shall look at V model. That will be followed by rapid application development. And sometimes we abbreviate that as RAD. And prototyping will follow RAD. After prototyping, there's also another methodology similar to prototyping, but we call that throwaway prototyping. And that will be followed by parallel development. Phase development follows parallel development. We have time boxing model. And finally, agile development, which is still evolving today. Actually, of these, in the list, waterfall model is the oldest methodology in industry. And then the latest we have, which is still evolving today, is agile development. So let's go to introduction. In the first lecture, we discussed systems development life cycle, what we abbreviate as SDLC. And we said this is the approach of developing computerized system, the development life cycle. It has elements, what we call phases. And we mentioned them. There were 4 major phases of systems development life cycle. From planning, and planning has its important activities, ranging from systems requisition, feasibility study, and project management plan. And then after planning, we mentioned analysis, which also has its important activities. One of them, the first one is in analysis, strategy, followed by requirements discovery. And after that, there's a system proposal. We looked at that in the first online lecture. And then after analysis, there's design. Design also has its strategy. It can be in-house, it can be outsourced, or simply off-the-shelf software solution. And then there are other design elements for database, for interface, for network, for program, for security, and others. So starting from planning, going to analysis, then design, finally we end with the implementation, which is the programming itself. Programming, conversion, moving from old system to new one, and how that can be done. We discuss all those. And finally, the system goes into operations and the support phase. Now, methodology is a formalized approach to implementing the systems development life cycle. Those 4 important phases I've just mentioned, that is planning, analysis, design, and implementation, can be executed in different ways. And this is actually the definition of methodology. A formalized approach to implement systems development life cycle. When you have a problem, to get a particular solution, you may take different approaches. Or one person may take approach A, another one takes approach B, and the third one takes approach C. And at the end, you expect all the three to come up with the same solution. Maybe I can give you an example from O-level mathematics. If you are asked to solve a simple simultaneous equation, you may use elimination method, you may use graphical method, or you may use substitution method. By the end, you get the same answer, but the ways are different. So methodology in the context of computerization is explaining different approaches you can use to develop a system. So at the end, you have your system. So if the work is given to maybe 3 different groups, one group, let's move up, may choose to use waterfall model, another one uses V model, and the third one maybe goes for prototyping. So the steps are going to be different, but at the end, you expect each of those to come up with the solution to the given problem. So there are many different systems development methodologies, and each one is unique based on the order and the focus it places on each system's development life cycle. So those are planning, analysis, design, and implementation. Some methodologies are formal standards used by government agencies, while others have been developed by consulting firms, and they sell this to their clients. Now, the first methodology we're going to look at is what we call waterfall model. And sometimes we call this linear sequential model. When you see the diagrammatic representation of waterfall model, now you see the 4 phases of systems development life cycle clearly coming up from planning, analysis, design, and implementation, and finally, the system is obtained. Now, let's look at this approach into some detail. The original structured design methodology that is still used today is waterfall development. Actually, this one dates back to 1980s. 1980s, it was popular up to today. Some professionals are still using it. Now, with the waterfall development-based methodologies, the analysts and users proceed in a sequence from one phase to the next. Now, when you look from up, from planning, the arrow is pointing to analysis. That means after completing planning work, analysis follows. Then design follows analysis, and implementation follows design. Maybe the question is, why is it called waterfall model? Water naturally flows in one direction. It doesn't reverse. It doesn't go backwards. It flows in one direction. That's why we call this waterfall model. So the implication is, after planning phase, once you have completed that, you move to analysis, you don't go back to planning. Once you move from analysis to design, you don't go back to analysis. And in the same way, when you have reached the implementation phase, you are not expected to go back to design. So that approach is a waterfall. The key deliverables for each phase are typically very long documents, hundreds of pages or so, and are presented to the project sponsor for approval. Once you have completed one phase, for example, planning, you have to come up with the documentation and report to the project sponsor. So if there's approval from planning, you can go to analysis. So we're saying once the sponsor approves the work that was conducted for a phase, the phase ends and the next one begins. This methodology is referred to as waterfall development because it moves forward from phase to phase in the same direction as a waterfall. Now, this methodology, the waterfall model or linear sequential model, has some benefits and also some disadvantages. So the two key advantages of the structured design waterfall approach are that it identifies system requirements long before programming begins. Now, the fact that you concentrate on planning and analysis and you commit a lot of time to do that work means you are going to come up with thorough work and the requirements may be sufficient or detailed before going to programming. And it minimizes changes to the requirements as the project proceeds. So there's no need to waste time to go back. So the two key disadvantages are that the design must be completely specified before programming. So this may take a very long time. Planning and analysis may even take a year or more before any coding work can start. So the next model or the next methodology is the V model. As I mentioned at the beginning, if you're a programmer or you're an analyst, you may choose to work with the waterfall model. Or you may choose this one we're going to look at, the V model. Now, the V model has two arms. There's the left, where you see requirements, modeling, structural design, component design, and code generation. Actually, those four elements capture and summarize the four important phases of systems development life cycle. Planning and analysis are captured in requirements modeling. Then the design is captured in structural design and component design. Then once those are done, the code generation, the implementation, the programming comes here. Now, one special feature of V model I want to mention is it concentrates on quality assurance. It emphasizes quality assurance. That's why on the right arm of the V, you see a series of testings being done. From unit testing, that's the test for a model of a program, to integration testing, when you have modules combined, then to overall systems testing, then finally, the acceptance testing, which is testing done against requirements submitted earlier by the user community and management. So this is the V model. It assures quality through a series of testings from unit, integration, system, and final acceptance. Acceptance testing is done to ensure that the system requirements that were originally communicated by system users and management are indeed reflected from the final system that is being delivered. So the V model depicts the relationship of quality assurance actions to the actions associated with the communication in project initiation and requirements gathering, modeling, which is aspect of analysis and design, and the early construction activities. Construction is now programming, the art of programming. As software team moves down the left side of V, basic problem requirements are refined into progressively more detailed and technical representations of the problem and its solution. So from architectural design, the move is to component design. Actually, the architectural design is at higher level of abstraction. And then component design is a bit refined. And then after that, code can be generated. Once code has been generated, the team moves up the right side of V. That is now the testing side. Moving from unit test, integration, system testing, and acceptance testing. So that ensures quality software is delivered for productive use. So the third methodology we're looking at is rapid application development, what is abbreviated as RAD. A second category of methodologies include rapid application development based methodologies. This is a new class of systems development methodologies that emerged in the 1990s. They are still popular up to today. From RAD characteristics, it actually speeds up systems work. So RAD-based methodologies attempt to address both weaknesses of structured design methodologies by adjusting the system's development life cycle phases to get some part of the system developed quickly. RAD encourages and promotes software reuse. Once you have programmed a component, if you get this component used for the systems work we are doing now, in the future, in another project you're going to work on may require the same component. So RAD enables this to be used quickly, and that saves a lot of time. In this way, the users can better understand the system and suggest revisions that bring the system closer to what is needed. So when you are using RAD, or rapid application development, what you program within short time, when it is demonstrated, the users can also be educated about the system, and they can better understand it and tell you more about the expectations from the system. So most RAD-based methodologies recommend that analysts use special techniques and computer tools to speed up the analysis, design, implementation phases. So there are some tools for automation in RAD because the purpose is to promote quicker work. So some of these are case tools, fourth generation of visual programming languages that simplify and speed up programming. For example, Visual Basic. When you work with Visual Basic, the interface is normally friendly, and you can program the business logic and link this to a database of your choice. The simplest can be Microsoft Access. You can also use SQL. You can use Oracle or any other database. So, prototyping is actually in the category of RAD-based methodologies. That's the picture of prototyping. Now, when you look at the diagrammatic presentation, one thing you can note is the four important phases of systems development life cycle are represented, but they are following a particular format of this methodology, the prototyping. So this is what happens. Under prototyping, a general planning is done. Identify the problem, do feasibility studies if necessary, then come up with your project management plan. From planning, you move to analysis. So, with the established problem at hand, what you do is do quick analysis, design a quick system, and implement, code it. Come up with a working system, what we call system prototype. That is running software. So what you're going to do is to present or to demonstrate the software to the users. You tell them, you demonstrate to them the software, present functionalities of the software, and ask them if this is their expectation from the system under development. When you do this, you are creating awareness of the entire system. From what they see, they can be able to tell, well, this function is okay, but that one needs to be improved. This feature is okay, that one needs to be improved. So, based on their suggestions, their comments, you go back to analysis. You do the second analysis, second design, and second implementation. So you're going to come with the prototype 2, which will be an improved version of prototype 1. So again, you demonstrate prototype 2 to the same users. You tell them, based on their communication, these are the improvements you have made. They see it, they feel the system, they try to do a bit of practice. And then from there, if problems are still coming, let them communicate to you. Because the purpose is to come up with quality software. The software that is going to solve problems of the business. If there is more complaints, you still go back to analysis, design, and implementation. Now you can see it is iterative. That arrow from design here is from the overall box, pointing from this design middle, is pointing to system prototype. If this prototype is not complete, then the arrow goes back. That means the technical team is going to do more work. After getting the next version of this system, they still present it. And then finally, if users agree this is the right system, it goes to implementation, and then the system goes to productive use. So that is the prototyping in brief. So we're saying a prototyping-based methodology performs the analysis, design, and implementation phases concurrently. And all three phases are performed repeatedly in a cycle until the system is completed. So this is the cycle. Comes here, goes there if there are problems, more work is done to generate the next prototype, present it to users. If they're not satisfied, work is done, and that is an iterative process. Up to when users are satisfied, then it goes to implementation, and you stop there. So with these methodologies, the basics of analysis and design are performed, and work immediately begins on our system prototype. The first prototype is usually the first part of the system that the user will use. This is shown to the users and project sponsor who provide comments which are used to reanalyze, redesign, re-implement a second prototype that provides a few more features. So this process continues in a circle until the analysts, users, and sponsors agree that the prototype provides enough functionality to be installed and used in the organization. So that's how the final system comes. After continuous work, after continuous refinement, then when the last prototype is accepted, it becomes the operational system. So after prototyping, there's another methodology called throwaway prototyping. Throwaway prototyping. It is similar to what we have just discussed, but there's some differences. So throwaway prototyping-based methodologies are similar to prototyping-based methodologies in that they include the development of prototypes. But the prototypes are not the same. The first one we called system prototype. So for this one, we're going to give it another name. Now, this is a diagrammatic presentation of throwaway prototyping. There's common planning done for the entire system. After that, overall analysis is done. Then, there's this arm of work where part of analysis is done for a particular feature, design is done, and implementation is done to get what we call design prototype. And this design prototype is not a working system. If you compare this one with the first one, the first system prototype is software that is working. But here, the design prototype simply presents systems feature for a particular design. It may be a form for order in an e-commerce system. That can be an example of a design prototype. Or an online form for students' application, those who want to apply to join university. That it can also be prototype first. So we call that a design prototype. So when the users are satisfied with the design of a section of a system, it's a smaller part actually, then they can tell the technical team, and the team will move on with this concept. So we call that throwaway prototyping. So once the fairer version of design is obtained, then the proper design can be done. And after that, implementation follows, so that you get your final system. So the throwaway prototyping based methodologies have a relatively thorough analysis phase that is used to gather information and to develop ideas for the system concept. That's why we call it throwaway, because it is generated to be presented to users to seek their acceptance. Then if they approve this system feature, then it can become the design element to be carried forward for implementation. So each of these issues is examined by analyzing, designing, and building a design prototype. So we should get this clear, that throwaway prototyping generates a design prototype. But the original prototyping we looked at before generates a system prototype. A design prototype is not a working system. It is a product that represents a part of the system that needs additional refinement. And it only contains enough detail to enable users to understand the issues under consideration. So the next methodology is parallel development. Waterfall, or the linear sequential methodology we looked at the beginning, normally consumes a lot of time. It can be many months, or even years and years. So in order to speed up or to reduce the time taken by waterfall model, other models evolved. And one of these is parallel development. So this is the approach. The parallel development methodology attempts to address the problem of long delays between the analysis phase and delivery of the system. So instead of doing design and implementation in a sequence following one after the other, it performs a general design for the whole system, and then divides the project into a series of distinct projects that can be designed and implemented in parallel. Now, what we're saying is, instead of following the linear approach, moving from planning, analysis, design, and implementation, you can have one overall planning. Then you have one overall design, which you then split into a number of designs, such that one design moves in parallel with the other design. So you create what we call sub-projects. From one project, you may create 3, 4, or 5 different sub-projects. And each of these is implemented in parallel to others. Once all sub-projects are complete, there is a final stage of systems integration. You combine all of them so that you get your overall system. That is the diagrammatic presentation. Now, from that diagram, there's one overall planning for the entire system. And also, analysis follows in the same way. But when you reach design, you have your overall design. So this design is split into 3 different parts. This is the first for sub-project 1, the second for sub-project 2, and the third design for sub-project 3. So you can see there's a clear division of labor here. So that work is done, the middle is done, and the last one here is also done. So the purpose of dividing the original design into 3 parts is to speed up the work of systems construction or development. However, much as these 3 are proceeding in parallel, at one point they have to be combined. That's now what we call integration. They have to be combined so that the overall system comes here. So another approach after parallel development is what we call phased development. Now, for phased development, the problem may be big, but the best way to go or to proceed is to divide this problem or to break down the entire problem into smaller parts. Build part number 1, based on priority, get your system version 1 Then after that, you move to the second part, build, come up with the version 2 by adding additional software components to version 1. So this is what we call phase development. So a phase development methodology breaks the overall system into a series of versions that are developed sequentially. Develop version 1, after that move to analysis 2, come up with version 2, move to analysis 3, come up with version 3. And this version 3 is going to be the final system. The analysis phase identifies the overall system concept and the project team, users, and project sponsor. And then categorize the requirements into a series of versions. The most important and fundamental requirements are bundled into the first version of the system. What the organization needs most from the system is given priority for development. The analysis phase then leads into design and implementation, but only with the set of requirements identified for version 1. Requirements with the priority number 1 are analyzed and programmed to get version 1 of the system. Then after that, the work continues with the second set of requirements to get version 2. So this is how it moves. You have here overall analysis divided into 3 sets of requirements based on orders of priority. So for the first set, when you look at the right arm, there's analysis, design, and implementation. From that, you get system version 1. This is what the organization needs urgently. So they may be using this as the work continues with the version 2 to get the next version of the system. So after version 2, if the budget and time allow, then the work can continue for system version 3. And this system version 3 also includes version 2 and version 1. So actually, system version 3 is the overall system developed. And then the next methodology is what we call the time boxing model. In the time boxing model, the basic unit of development is a time box, which is of fixed duration. You know, in a natural situation, when you are doing some work, the time allocated is determined by the gravity of the work. If it is hard work, you give it more time. If it is simple work, you give it less time. But that's not the situation for time boxing model. For time boxing model, time is the focus. If you set the time box to be 2 hours, then you have to fix an activity that can be completed within that time. Since the duration is fixed, a key factor in selecting the requirements or features to be built in a time box is what we can fit in that time box. This is in contrast to regular iterative approaches, where the functionality is selected and then the time is allocated to deliver that. Time boxing changes the perspective of development and makes the schedule a non-negotiable and a high priority commitment. So the focus is on time. The time is allocated and activities must be completed within that time frame. With a time box of 3 stages, here we're demonstrating an example. The project proceeds as follows. Let's look at this diagram. Let me use that to explain. Now, assuming the entire system's development life cycle is summarized into 3. And the phases are requirements, build, and deployment. Now, using time boxing model, you have to allocate equal time to each of those phases: requirements, build, and deployment. If you assign 2 months for requirements work, you should also assign the same time, that is 2 months for build, and the same for deployment. Now, if you are going to have requirements divided into 4, say for the case of this demonstration, you will have also teams working in these phases. You should have team for requirements. Maybe you have 3 people doing requirements work. Then those who are going to build the system, maybe 4. And the deployment, let's say you have 2 people. So the rule is, where somebody is, the person remains there. If you are building the system, you don't do the work requirements analysts are doing, and you don't move to deployment area. So you remain in a building. So in the same way, if you are deploying the system, you don't participate in the building and you don't go for that requirements analysis. So the jobs are specific to team members. Now what happens is, once the requirements team has finished the work in time boxing 1, what we have written there as TB1, the handover their output to the build team. Now, as the build team starts the work, the requirements team receives input from TB2. So for them, they are continuing to work. Much as the deployment people are still doing nothing. So that is the order of time boxing model. And then the final system development methodology, the one that is still evolving today, is what we call the agile development. This is a third category of systems development methodology. And these are programming-centric methodologies. The focus is on programming. It emphasizes programming. It emphasizes change. And it needs competent programmers. It needs people who are flexible, people who can accommodate change in time. If a customer comes and presents a complaint, that complaint should be taken immediately and addressed. Actually, in agile development, the technical team or a team of programmers frequently meets the user community to present developments. So they focus on streamlining the system development lifecycle by eliminating much of the modeling and documentation overhead. So the emphasis is on technical work, programming, less on the logic of diagramming, documentations, and so on. Instead, projects emphasize simple, iterative application development. Change is what software development is very much about. Now, you compare this with the waterfall model. In the waterfall model, once you have completed a particular phase, you don't go back to it. Once you have moved to the next one. But that's not the case for agile development. For agile development, whatever change comes must be accepted and addressed. So changes in the software build, changes in the team members, changes because of new technology, changes of all kinds that may have an impact on the product they build should be accommodated, should be addressed. Support for changes should be built in everything we do in the software, something we embrace because it is heart and soul of software. An agile team recognizes that software is developed by individuals working in teams, and that the skills of these people, the ability to collaborate, is at the core for the success of the project. So competence in programming is the requirement for agile development. And the ability to collaborate, to do teamwork, is important for the success of systems development. So here are some human factors for agile team. Proponents of agile software development take great pain to emphasize the importance of people factors. A number of key characteristics must exist among the people on an agile team. So these are the soft skills expected from the team in agile development. Competence, specific software-related skills. If it is going to be mobile programming, this will be well-versed within mobile application development languages. If it is going to be database programming using Oracle, they should have skills in that. If it is going to be object-oriented programming, they should have skills in that. Common focus. There should be one common goal, and everybody must be working to achieve that goal. Collaboration. Team members must collaborate with one another. They should listen to each other. They should support each other. They should discuss ideas openly, and they resolve conflicts in a friendly way. Decision-making ability. They should be quick in reaching to decisions expected. Otherwise, delays may come in. Also, mutual trust and respect among the team members is important for the success, because changes come. There should be a common goal and competence. And all these require mutual trust and respect at the foundation. And then they should have that spirit of self-organization. They don't need a special leader to lead them, much as may have one. But it's expected that the team members should agree to each other, should relate to each other, should have that spirit of self-organization. Now, one of the agile development methodologies is what we call extreme programming. We normally abbreviate this as XP. Extreme programming is founded on 4 core values: communication, simplicity, feedback, and courage. And you can see all these are values of agility. These 4 values provide a foundation on which XP developers use to create any system. The developers must provide rapid feedback to the end users on a continuous basis. Developers must make incremental changes to grow the system. Now, this means as users continue to communicate, the system should be enhanced with that communication. So when these technical people pick the requirements from user communication, they should be able to program that into the system. And that's how the system can grow. They must embrace change, and developers must have a quality-first mentality. Extreme programming, XP, also supports team members in developing their own skills. So diagrammatically, that is how it goes. There is one overall planning. Now that box is similar to prototyping-based approach, but what is good here is this is a special team, experts in programming. They continuously listen and capture changes that come from users, and they accommodate them, and they're in touch with user community in terms of presenting what they have done and also listening to the users to accommodate any change that can arise. So that is the extreme programming methodology. So in summary, we had the waterfall or linear sequential, the V model, rapid application development, prototyping, throwaway prototyping, parallel development, phase development, time boxing model, and finally, the agile development methodology, which we have summarized with the extreme programming. So a programmer or a technical team may choose any of these methodologies for working when developing systems. So that's the end for this presentation. You get this summarized PowerPoint in a move shape together with the handout for this presentation. And then there's also an open question you'll find in the discussion forum. Please express where you have challenges so that we can respond to them. Thank you. Goodbye. BBC2 students.